Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome once again to Mewa Digital Hub channel. Today we're going to study paper 2. So we're going to look at the overview of paper 2. Tutaangalia. If I get time, I'll finish with the paper 1 that I currently started last week. So this is mainly to prepare KCSE students to how KCSE questions are solved. So majorly it's just mostly to pass through the questions and what topics were included for the last year's KCSE. Okay, so for question 1 we had things to do with the periodic table. So if you don't have any knowledge of the periodic table, it's better to start studying it from now. And it's not a big topic, it's just a short topic. So it's some extra things, but it's very important for other questions. It doesn't only include question 1, but it also includes other questions. Okay, so for the first question was about periodic table, but the second question was mostly about sulfur. So if you see here, it's about sulfur and its compound. So paper 2 are mostly concentrating on the compound, nitrogen and its compound, especially the production of certain substances, application questions, etc. So this shows the steps in the contact process. We also have Frasch process and etc. And then we have organic chemistry. Okay, organic chemistry. I think it includes both, but mostly it's of organic chemistry 1. But I think from the diagram it also includes organic chemistry 2 because of alcohol or ethanols and the presence of saponification and etc. Then we have question 4. It includes about electrolysis. It also includes about and what do you call it? We also include radioactivity and etc. So it's mostly about electricity, the EMF and etc. Then okay, now if you go ahead go to question 5, then it includes about the reaction rates. Okay, so the topic that kind of was ignored by students was usually was set in the previous paper. So this one also again molarity, and also most of it it's about molarity, and still is rate of reaction. State the meaning of the 6th question was including about heat, so it was about enthalpy changes. Okay, so you should know the basic concepts of enthalpy changes. And then we go to, I think it's solubility, if I'm not wrong, but it's about permanent temporary water, I think soft water, hard water, the differences between soft and hard water. So about solubility mostly. So if you look at the different solubility of salts at different temperatures. Okay, and then we that's all. So you kind of think it's very short, but it's usually, when answering such questions, it's really long, but still is out of 80. Okay, now let's start with question 1. For the first question, periodic table, which is mostly tested, you need to know the chemical families. You also need to know the positioning of different elements, their periods and their groups. So for the first question, but before even drilling at the questions, you should know that we have 8 groups in the periodic table for the first 20 elements. If you go to the university, that's when you learn other elements, but for the first 20 elements, which are the key ones, it has 8 groups. And then we have 1, 2, 3, 4, 5, 6 periods. For the periods we write it in numbers, for the groups we write it in Roman. So question S asks you about element Q. Element Q belongs to period 5 and group 6. Group means that it has 6 electrons in the outermost energy level, period 5 means that we have you have around 5 energy levels. So it can be 2 to 18. For now, you just need to know that the energy level holds at most 8 electrons. If you reach university, that's when you'll be taught 32 electrons, 64 electrons. But for now, let's just see where element Q belongs to. So we've been told that it belongs to period 5. So it is in this row and group 6. So element Q is here. So simple. Place the element in the correct position, which we did. For question B, consider the following ions, which is G2 minus, K minus, and M plus. Now, if you get something like this is an ion, and an ion is a charged atom. Okay, so probably if someone was asking you about the definition of ion, you should tell him that an ion is a charged atom. It either has a negative or a positive charge in it. So for the ones that have a negative charge, we call them anions, and for the ones that have a positive charge, we call them cations. Now, for you to know the electronic arrangements of ion, first we go back to its atomic structure or atomic electronic arrangement. So we search for the atomic electronic arrangement of J atom, not ion. So when you look at J belongs to period 3 but group 6. So period 3 but group 6, so it should be 286. Why did I write 286? It's because it belongs to group 6, which is 6 electrons in the atom's energy level, and period 3, it has 3 energy levels. For K, how do you write K? K, now look at where K is located at. K belongs to group 7 but period 3, so it should be 287. Okay, remember the letters do not represent the actual element, so don't go and presume that this one is chlorine or another element. So then we have M. Now if you look at M belongs to group 1 but period 4, so most probably it should be written to as 2881. But now what about its ions? For the first one, G2 minus or J2 minus, the electronic configuration of this will be 288. That is because it gained 2 electrons. So when you observe something like 2 minus, just know it gained 2 electrons. So therefore, from having 6, if you add 2 to 6, you get 8. So it becomes 288. For K minus, it means that you just added 1 electron into it, therefore having 288. And for the M plus, you lost. Addition means you lost an electron, therefore the protons are more than the electrons. If the protons are more than the electron, the positivity of the atom increases with a decrease in electrons in that atom. So this means that it lost that 1 lone electron in the atom's energy level, hence giving you 288. So write the electronic arrangements for each. So most probably it's just the same. I don't know why such question was asked, but who knows. So this, all of them gives you 288, and also this one also gives you 288. So unless you're quite clever, but if you start asking yourself why the answers are the same, then it might lead to a lot of thinking and confusion. So let's go to the second question now. So the second question is asking you about the ion, okay, with the largest ionic radius. So you've been told select the ion with the largest ionic radius. Okay, so the ones which have a large atomic radius are the ones which have a higher period, so we just remain with M, N, and P. Okay, so M being 2884, N being 2885. So just know that it looks like the way, but it shouldn't be looking like this. Just know that M has four periods, and also NP, but also there's Q. Okay, there's Q as well. There's Q as well, but for Q is gaining. Therefore, even if it gains, it means that it will start to reduce in size. So, but this one wasn't there. So M and MP. If you look at it, let's look at the select the ion with the largest ionic radius. So it's referring to the J, K, and M. Oh, sorry, I thought it was referring to the whole period. So it's referring to the J, K, and M. So between those three, which one has a large ionic radius? Okay, which one has a large ionic radius? Okay, so for the J, let's look at J. Originally it was 16 protons, 16 electrons, but when it became J2 minus, it now has 16 protons by 18 electrons. For the K, it was 17 protons, therefore 17 electrons, but when it became K minus, it eventually became 17 protons and around 18 electrons. Okay, now for the M had 11, I say 11, 10, 18, 19 protons and 19 electrons, but when it became M plus, it had 19 protons but 18 electrons. Okay, now if you look at 16P and 18, the attraction is not that strong as compared to the K1. So the K1 has somehow a slightly larger attraction because it has more protons compared to J. So therefore the J's nuclear force of attraction is somehow weaker compared to K. As for M, it has a higher nuclear force of attraction because of the superiority of the protons. The protons are more than the electrons, therefore the electrons are attracted towards the nucleus. So therefore what I mean is, if the protons here are more, the electrons will go further inside, and therefore reducing that size, or making that ionic size to be small. But now if the electrons here are more than the protons, the distance will be further away because the electrons will be repelling against the protons. In this case, the J's nuclear force of attraction is somehow weaker compared to K, because K has more protons while J has less protons. Therefore, the nuclear force of attraction is somehow smaller. So as a result, the outermost electrons tend to push itself away from the nucleus, also increasing in size. Okay, hope you've understood me. I can explain it in Kiswahili if you wish as well. What I mean is, hizo electrons ambazo ziko nje zikiwa kidogo nyingi kuliko protons, huwa zitajaribu kuenda mbali. So it doesn't want to be near the nucleus. So zikienda mbali, the size ya hiyo atom or ion inakuwa kubwa. So select the ion with the largest ionic radius is probably J2 minus. And the reason why this is because it has lowest nucleus charge, and the electrons, okay, and the electrons are not strongly pulled to the nucleus, pulled to the nucleus. Okay, as compared to K, it has more protons, therefore the nucleus charge will be higher, so to the nucleus. So if it has more protons than J, it means that the nuclear force of attraction will be slightly higher, therefore it will be very smaller compared to J. For question C, complete table 1 by filling in the formula of the compound formed and the type of bond between the elements shown. So we have A and B, so which formula and the type of bond that we have? Okay, let's look at A and let's look at B. For group 1, 2 and 3, they are methods. So group 1 to 3, all of them are methods. From group 4 to 8, 4 to 8 are usually non-methods. Okay, so let's put that in mind. So for A and B, let's look at A. A is a method. B is therefore a non-method because it belongs to group 5. So if a metal and a non-metal react, they tend to form a bond called ionic bond. Ionic bond is a type of bond that holds a metal and a non-metal together because of that charge between them. A will have a positive charge and B will have a negative charge. So those charges usually attract each other to form ionic bond. So for A, you'll have A positive because it will lose one electron from the group. If you have group 1, it means that you have a valency of 1, therefore you lose one electron. For B, since it's group 5 and it has 5 electrons, then the atomic energy level, so therefore it will tend to have a valency of 3, it just gains 3. So as a result, it will have 3 minus. Okay, so with that, the A takes the 3 and the B takes the 3, they tend to interchange. So the A taking the 3 and the B taking the 1. So you should write it like this. So A3B. Most of the students tend to write it this way, which is very wrong, though it gives you the correct answer, but as time goes by, it's very wrong. Okay, because it is not maths. So don't try to compare chemistry with maths. There are some mathematical concepts in chemistry, but it's not still maths. So this one gives you a formula of A. Is it A3B? Yeah, it is A3B. So that's the formula of compound. So do not represent to the actual elements, and the type of bond that we have is called ionic bond. For G and C, let's look at G and let's look at C. G is a non-metal, okay, because we said it is for elements that belong to group 4 till 8 are usually non-elements. G and C. Am I tripping? Yeah, I'm correct. G and C. So we have G, which is group 4, therefore it will gain 4 electrons. So just write 4 electrons. For C, group 7, it gains only 1 electron, so it becomes C minus. So the G will take the 1 and the C will take the 4, so it will tend to be written like this, and this is your final answer. So GC4. And the type of bond that we have here, okay, the type of bond that we have here is called covalent bond. Okay, it's called covalent bond, not weak, because if you look at it, still we should say that it's a covalent bond. Okay, so the answer for that, we say GC4, and it's a covalent bond. It's because the bonds that we taught, it's just ionic bond, covalent bond, the dative bond is just part of covalent bond. There's also hydrogen bond. There are intermolecular forces in between those molecules, but still, for the atoms to be together, they are held by covalent bonds. So question D, explain the following observation. Electrical conductivity of F is higher than that of E. And I think it's very easy. So F is higher than that of E. So this one is higher than that of E is because of the electrons in the outermost energy level. So F usually has more electrons or more outermost electrons compared to the other element E. So the more electrons you have, the higher so the more delocalized electron you have, the higher the electrical conductivity. So it's very easy. The observation that I see here, F, the following, this is our observation. Obviously, the reason why do you see that is because F has more delocalized electron. So not need to write a lot of explanations. Chemistry is not like biology. Just answer or keep out the main key concepts. Element M is a stronger reducing agent than element D. Okay, stronger reducing agent than element D. So let's look at M and D. M and D. M, this is M and this is D. So one okay, they all belong to the same group, so maybe but they have different periods. So it means that M has one more energy level compared to D. Okay, so M is somehow bigger. This is M, and D is somehow smaller because of the energy levels. Now, for reducing agents, if something is reducing agents, it means that a stronger reducing agent means that it reacts faster. Okay, so and reactivity is looked at the easiness or easiness of losing or gaining an electron. So for losing electrons, for atoms that lose electrons, larger atoms tend to lose faster because they are somehow very far from the nucleus. Sawa, ikiwa electron ikiwa mbali sana na nucleus, hiyo electron inakuwa rahisi kutoka. So if it becomes easy to get removed or to lose an electron, it means that it is more reactive and it's a very stronger reducing agent. So the reason is very simple. M has a larger atomic radius than D, making it easy to lose electron because of lesser nuclear force of attraction. So the reason, again, M loses electrons more easily. Electrons more easily or is more electropositive. You can say is more electropositive or has weaker effective nuclear attraction. Has weaker effective nuclear attraction. So you don't need to explain a lot of things for just one mark. Effective nuclear attraction. Okay, for Roman 3, the melting point of element H is lower than that of element N. The melting point of element H is lower than that of element N. Where is H? H, or this one. So the melting point of H is lower than N. Again, the same reason that we have. N is bigger than H, right? So now we already know that N is somehow bigger than H because of the energy level. N has more energy level compared to H because it is one period ahead of H. So if it's usually bigger, okay, it means that it forms bigger molecules. So if it forms bigger molecules, the distance of the molecules or the nuclear force of attraction, the distance of the nuclear force of attraction is somehow smaller. So if it becomes smaller, it means that the strength increases. But if it's if it has small molecules, the distance between the molecules is very long. So it means that the nuclear force of attraction or the intermolecular forces are very weak. okay, and they tend to be broken easily. So the ones with large molecules, okay, or large atomic radiuses have higher nuclear force, have higher intermolecular forces. As a result, it becomes somehow harder to break them. But for the the smaller molecules, it becomes easier to break them. So ni ndogo, lakini ile distance between the molecules is long. So ikiwa ni long, yamaanisha ile strength between those molecules will be weaker. Lakini ikiwa ni kubwa, distance between those molecules inakuwa ndogo and the strength increases as well. So if the strength increases, this makes it harder to break those, thus having a higher melting point. So again, H has a small atomic size. H has a smaller atomic size. So weaker, or you can say weaker van der Waals forces. Weaker van der Waals forces, then N. Then N. So we finished with that question. So now let's look at question 2. Let me also increase the visibility. Somehow seems that is not visible enough. Now this one is called contact process. Okay, the main purpose of this is just to create sulfuric acid. Okay, and there's something called Frasch process. Frasch process is just a method of extracting sulfur. So this one shows the steps in the contact process. Okay, so you're getting sulfur deposits. Then we got sulfur after the extraction in step 1, which we did with using a Frasch process. And then in step 2, it means that you added oxygen to it to give you sulfur oxide, and then you added, most of the time I think is limited oxygen, then you added excess oxygen. Then you added water in step 4 to give you sulfurous acid. Okay, and then you added something here also. All in all, if I were to explain this, it will be a very lengthy lesson, but it's usually a very easy topic. Okay, so we usually use something called catalyst, in which our catalyst most of the time is vanadium 5 oxide. Okay, so which helps in converting sulfur 6 oxide into sulfuric acid. So hopefully, I think that one is produced. Okay, so just know that sulfur, you reacted with oxygen, sulfur 4 oxide, then you reacted with more oxygen to give you sulfur 6 oxide, you added water to it, and I think you get sulfurous acid, then you did something to it again, in which I want you to find out what thing did you do to that. Okay, what thing did you do to this for you to get sulfur 4 oxide itself? So but most we'll look into it. Okay, we'll look into it just right now. Okay, and I know what we added for you to get sulfur 4 oxide. Now, step 1 is known as the Frasch process. Describe how the process is carried out. A process, the whole process, and it's 3 marks, but the space is very minimal. I don't know where to write, but let me just write in at the periphery. So usually, the first step that we need to do, you usually put 3 concentric pipes. So 3 pipes. Okay, I'm just summarizing. So you use 3 pipes, concentric pipes. I'm saying so, concentric pipes that is usually drilled to the underground sulfur deposit. We usually drill it to the underground sulfur deposit, where you'll find the sulfur itself. Okay, and then the next step after drilling and using the pipes, then you pass superheated water into it. So you pass superheated water. You need to define at what temperature, at 170 degrees Celsius. So it's pumped through that outermost pipe. So there are 3 levels of pipe. So you pass it through the outermost pipe to underground sulfur deposits to melt. The reason why you do that, to melt sulfur. Okay, and then we also pass hot compressed air to the innermost pipe. Remember, the pipes are 3. So there's the innermost, there's the outermost. So you should know that. To the innermost pipe, you usually pass hot compressed air innermost. So make sure you highlight the innermost pipe. Okay, to push the molten sulfur. It's the main purpose is just to push the molten sulfur to the surface, to push the molten sulfur to the surface through the middle pipe, to the surface through the middle pipe. Okay, so if I were to summarize it, so we have 3 pipes, okay, which are drilled to the underground. So for the first pipe, we pass superheated water, that is the outermost pipe, so that we pass superheated water at 170 degrees Celsius so that you can melt sulfur, so that it can become molten. Otherwise, sulfur itself cannot pass through the pipes by itself. It's just solid, doesn't make sense. And then once you pass, you do that, you pass hot compressed air to force that molten sulfur to the surface. Okay, and that usually is passed through the middle pipe. So we've already described how the process is carried out. Set the optimum conditions in step 3. Well, where is step 3? So optimum conditions for you to get sulfur 6 oxide from sulfur 4 oxide. What are the optimum conditions that you require? For the first one is vanadium 5 oxide, which is written like this. I write it like this: vanadium 5 oxide. For the second one, that's a catalyst, we require pressure of at least 2 to 3 atmospheres, and then also temperature. So the main condition is temperature, pressure, but be specific when it comes to temperature. Most of the students, that's right, high temperatures of between what? Okay, between 400 to 450, or 450 to 500, depends with you. 450 degrees to 500 degrees Celsius. Some books may say 400 to 450, depend on the book which you're using, but mostly use the KLB version. So you can, okay, any temperature is usually accepted. If you write 460, if you write 480, or you write 500, is usually accepted. So any temperature between this range. So let's go to the other question. Identify substance A. So what is a substance that changes sulfur, sulfurous acid, mostly called oleum, okay, to sulfuric acid? What is that thing? That's not okay. So it's called concentrated. So we add concentrated sulfuric acid to oleum. Okay, sulfuric acid to dehydrate that, so that you can remove water from it. Remember, concentrated sulfuric acid is a dehydrating agent as well. So hopefully that answers your question. So when you have this right, now if you pass concentrated sulfuric acid, what it usually does, it removes the words H and the O, H2O. So if you remove H2O, you remain with sulfuric acid. Okay, so for B, for A, wait a minute. Yeah, for A, that is. For B now, you use water. Okay, we use water, okay, to make it somehow dilute, but we use water. Hopefully that answers the question. So we have B, water, and let's go to the other question. Question D, name the process that occurs in step 2. Name the process that occurs in step 2, and that process is called oxidation, because you're reacting sulfur with oxygen to get sulfur oxide. So you either use most probably I'll prefer students to write oxidation, but if it's possible you can write combustion. Don't write rusting. Don't write rusting. There's a difference. Some people write rusting instead of roasting, so you can write roasting, combustion, burning, whichever, but most of the time you use oxidation, because this is a process of adding oxygen into that sulfur. Question E, when concentrated sulfuric 6 acid is added to glucose, a black solid is formed. Identify the black solid. The black solid is carbon. This is because the sulfuric 6 acid usually dehydrates the glucose. So 6C6H12 or 6. Once you pass concentrated sulfuric acid into it, it dehydrates, giving you C, carbon, and water. So the carbons most of the time is 11, but I didn't balance, but make sure you balance it. Okay, so the black solid is carbon. State the property of concentrated sulfuric 6 acid illustrated in this reaction is dehydrating agent. Okay, so hopefully, wait a minute, state the property of concentrated sulfuric 6 acid illustrated in this reaction. Oh, for the reaction, okay, I think you're good to go. Now there's, okay, I don't know, there's a, oh yeah, by the way, there's a correction I'm supposed to do. Yeah, so there's a correction. I was saying that I'm confusing it with a lot of processes nowadays. Okay, now let's just overlook this part again, so that we can get a good view of what's really happening. Okay, now usually we have sulfur from the Frasch process, which we extracted from the sulfur deposit. Okay, from the sulfur deposit you'll obtain sulfur using the Frasch process. Now in step 2, we take sulfur, react it to oxygen to give you sulfur oxide. This gas, and then the sulfur oxide, which is also gas, you react it again with oxygen, but to give you sulfur 6 oxide, which is gas. But now this reaction is exothermic, not exothermic, so it's a reversible reaction. So if your temperature is not more enough, it means that sulfur 6 oxide can return back to becoming sulfur oxide. So that's why the temperatures are usually above 400 degrees Celsius or 450. So it's within that range. And we use a catalyst to speed up the rate of reaction as well, called vanadium 5 oxide. That's why in step 3 we get sulfur 6 oxide. Okay, but when it comes to step 4, now that in step 4, for you to get this is not called sulfurous. I don't know why in my mind I said sulfurous, but it's called oleum. Okay, for you to get oleum, you have sulfur 6 oxide. So that sulfur 6 oxide, you react it with sulfuric acid. Okay, you react it with sulfuric acid to give you now oleum. So hopefully that is understandable. Okay, even if you look at it, you have 2 sulfurs and you have 7 oxygen. So just ignore the part where I said, I don't know, you sulfuric acts as a dehydrating agent. So ignore that part. for now. So sulfur 6 oxide reacts to sulfuric acid to give you oleum. Now the oleum that you obtain from that reaction is now reacted to water, okay, to give you sulfuric acid, the sulfuric acid that you have now. But now the water is somehow added dropwise. Why? Because if you add add yote kwa mara moja, it usually makes that concentrated sulfuric acid to be obtained in vapor form, or to be collected in vapor form. That's why it's very essential when you reach step 5 to add that water dropwise, or somehow just adding it wisely enough so that it doesn't change to becoming vapor. And we don't want to obtain vapor, we want to obtain that liquid sulfuric acid. So hopefully that information is passed through and you've understood it. So sorry for the misinformation that I gave you at the initial stages when you are tackling question 2. So now the process in step 2, we just say it's called oxidation. Now let's go to question 3. For question 3 is about organic chemistry. It also includes organic chemistry too, because of alcohols and the saponifications. So the formula, we have the formula of 3 organic compounds, each having 2 carbon atoms. So we have C2H4, C2H2, C2H6. So we have these ones. So we have CnHn plus 2. We have CnH, is it N2N plus 2? We have CnH2n. We also have CnH2n minus 2. Okay, so we have CnH2n plus 2, CnH2n, and we have CnH2n minus 2. Okay, so CnH2n plus 2, you need to know what it is. These are alkanes. Okay, these are alkanes. These ones are alkenes, and this one are now what we call as alkynes. Okay, so alkanes, this is an alkane, because if you take 2 times 2 you get 4, 4 plus 2 you get 6. So this is an alkane. C2H2, if you take 2 times 2 you get 4 minus 2 you get 2. So therefore this one is alkynes. And for CnH2n, if you take 2 times 2 it gives you H4. So therefore this one is an alkene. So this one tends to take H2n, this one tends to take CnH2n minus 2, and this one tends to take H2n plus 2. And that's now what we refer to it as a different homologous series. Now, what is a homologous series, right? Now, homologous series, if the term itself, it just refers to the compounds with the same general molecular formula, but it usually differs with a CH2 group. Okay, CH2, because if you look at it, every alkane, the reason why alkane is different to alkynes, or the reason why alkyne is different to alkene, is because of the CNH or CH2 group. Okay, some has an additional CH2, the other one doesn't have, and etc. So just know that we have something described as saturated. We have things called unsaturated. The unsaturated part is usually the A and B. Okay, we call them unsaturated hydrocarbon. Okay, unsaturated hydrocarbon, because it has a double bond or triple bond. For alkynes we have triple bonds, for alkenes we have double bond. For the alkane we call it saturated hydrocarbon. Why? Because if you combust it, it gives you fully combusted CnH2n plus 2, in which it will fully combust to give you CO2 plus water. The others don't usually combust fully, that's why it's unsaturated. Okay, so state what is meant by the term homologous series. They're just compounds with the same general formula, as same general molecular formula, compounds with the same, because all of them have CH, with the same general molecular formula. But now what differs between them is just but differing with a CH2 group. With a CH2 group. Hopefully that is understandable. Now we have compound B. Now compound B is the first member of its homologous series. Write the formula of the fifth member of the same series. So B is alkyne. So an alkyne usually takes this approach, CnH2n-2. So if it's 5, it means carbon atoms are usually 5. So we take H 2 times 5, then minus it by 2. So as a result, it gets C5H 10 minus 2, 8. So it's C5H10. Wait a minute, it's the first member of its homologous series. Compound B is the first member. Oh, so it's not, no, sorry. It's the first member. So if C2 is the first member, means C3 is the third, C4 is the fourth, C2 is the first, C3 is the second, C4 is the third. So therefore, this one should not be C5. So the fifth member will be C6. But still, it doesn't make sense. Or is it because there's no... Oh, okay, I've understood. I haven't heard of methane. So then we have C6, H 6 times 2 minus 2. So 12 minus 2 is 10. So C6 H10. H10. So it's a very tricky question, unless if you're careful enough, you'll try to understand it. So if the first one is C2H2, there's the C3, this is the second, the third will be C4, the fourth will be C5, and now the fifth will be C6. Okay, so which we refer to as hexane. So hopefully that is answered. Explain why compound A is described as being unsaturated. And we've already stated the reason is because of the presence of the double bond. Okay, it's because of the presence of the double bond. So that's a direct answer. You don't need to. So carbon does not have the maximum number of hydrogen atoms. That's another reason, but the main reason is because of it has a double bond, double covalent bond. It has a double covalent bond, okay, between the carbon atoms, not between the hydrogen atoms, between the carbon atoms. Now let's look at the final part, this one. So this might be the final. Is it the final? No, not yet. We haven't answered fully the question. Okay, for question D, the flow chart in figure 3 shows reaction involving compound B. Okay, involving compound B, which is calcium carbide. And then we have step 1, we have step 2, we have step 3. For now, let this be the last part. Okay, let this be. We'll continue from there. From the next lesson, we might schedule to tackle paper 2 2024. But for now, let's leave that because I don't want to do something lots of questions and the student doesn't understand the first two. So I don't want the video to be long enough. So with that, let's leave the lesson there, and don't forget to subscribe to Mewa. Okay, don't forget to subscribe to Mewa Digital Hub and share it to your friends. So if you're watching it through YouTube channel, share it to your friends so that they can benefit as well, and share this video to your friends. Okay, because it's very few people that usually share. So when you tend to share, you also, yani Mungu atakubariki pia, yani your information flows very smoothly. So don't be stingy with information. Also, I have my own YouTube channel which focuses on the maths, called Mind Was Ray Tutor. So if you are mainly focusing KCSE students and also KCSE students, so for Form 4s that are currently doing KCSE, you can follow this channel for more math content, and for KCSE students, I'll also encourage them to watch this channel as well. So with that, all in all, don't forget to subscribe again, and we'll meet next time in the same place but different presentation. Okay, wassalamu alaikum warahmatullahi wabarakatuh.